Hi, my name is Justine Harkness, and in this video, we'll look at how to identify alkynes. Alkynes are a type of unsaturated hydrocarbon that contain at least one carbon-carbon triple bond. And because of this triple bond, the carbons in the alkyne functional group must be sp hybrid. sp hybrid carbons will often contain 2 pi bonds. So let's take a look at an example of an alkyne. So here we have ethyne, and we will be talking about nomenclature in a later video, but let's just use this example to look at the types of bonds that we see. So each carbon in this molecule has 2 sigma bonds. These are the bonds in blue, sigma bonds being the single bonds that connect the atoms in a molecule. And to get to that triple bond, we have 2 pi bonds, adding this second and third bond between our 2 carbons. So because of those 2 pi bonds, each of these carbons would be sp hybrid. However, the presence of an sp hybrid carbon does not necessarily indicate that a molecule is an alkyne. You have to see that triple bond between those 2 carbons. And we'll look at some examples of where sp hybrid carbons are not actually alkynes. So let's dive into those examples. So here we need to determine which of these following molecules are alkynes. So what we're going to look for is a triple bond between 2 carbons. So let's start with example A. Just at first glance, we notice on the right side of this molecule, we have a triple bond between these 2 carbons. So this would be an example of an alkyne, specifically a terminal alkyne, since the alkyne functional group is at the end of the molecule. Now, example B gives us a structural formula, and something that you may notice on first glance is that with these 2 central carbons, they do not have any attached hydrogens. And this is a really good indication, just at first glance, that we might have an alkyne. So let's draw out its Lewis structure to confirm. So we have our carbon on the far left. It has 3 hydrogens attached to it. And it has another bond to carbon. Now notice this second carbon is only attached to one other carbon. It doesn't have any hydrogens attached to it. And that third carbon is attached to a methyl group. So looking at those 2 central carbons, what we notice is that each one of them only has 2 bonds. So this molecule as drawn is not very happy. In order for each of those central carbons to have the 4 bonds they need, we would have to add 2 more bonds to make that alkyne. So now that we have 4 bonds, this molecule would be happy. And because of this carbon-carbon triple bond, this would be another example of an alkyne. So whenever we see carbons that are attached to only a carbon on the left and only a carbon on the right, that is a good indication that you have an alkyne. Now let's take a look at that third example with C. If we look at this central carbon in between those double bonds, this carbon is in fact sp hybrid. But is it an alkyne? This carbon has double bonds on both sides. We do not see that triple bond that we need to see in order to identify it as an alkyne. So because of the fact we only have double bonds, this molecule would be an alkene, not an alkyne. So now you should feel more comfortable identifying alkynes.